The atomic mass or the mass of an atom is actually very, very small because atoms are extremely small. In the 19th century, scientists could determine mass of one atom relative to another by experimental means. The weight of an atom is determined by the number of neutrons and protons that are present in the nucleus. The atomic mass is the sum of the protons and neutrons in the nucleus. Hydrogen, being the lightest atom, was assigned a mass of 1 without any unit, and other elements were assigned masses relative to it. The current system of atomic masses was instituted in 1961 and is based on the mass of 12C. Carbon has an atomic mass of 12. Since there are 6 protons in carbon, remember, it has an atomic number of 6 and therefore must have 6 protons. It must have 6 neutrons. By definition, the atomic mass of a single 12C atom is exactly 12 atomic mass units, denoted by the abbreviation AMU or U. The masses of all other elements are based on this standard. Atomic mass unit. A unit used to express the mass of an atom equal to exactly 1/12 the mass of a carbon-12 atom. Today, AMU has been replaced by U, which is known as unified mass. Average atomic mass. An element can exist in a number of forms called isotopes. Isotopes are forms of the same atom that vary in mass. For example, hydrogen can exist in 3 isotopes having different atomic masses as shown here. To find the average atomic mass of an atom, we take into account all of the isotopes that exist and the percentage of each type. For example, carbon has the 3 isotopes with relative abundances and masses as shown against each of them. The calculation of the average atomic mass is a weighted average. This is the sum of all nuclide isotope masses multiplied by their natural abundance. From these data, the average atomic mass of carbon can be found out like this: 0.98892 into 12U plus 0.01108 into 13.00335U plus 2 into 10 raised to minus 12 into 14.00317U equals 12.011U. This weighted average is the relative mass listed in the periodic table. The relative percentage of each nuclide isotope appears to be similar throughout the world. Molecular mass. Molecular mass is a very simple concept to understand. Look at Mohan here. He is playing with 3 marbles. The weight of all the 3 marbles together will be the sum of the individual masses of the 3 marbles. That is, 1 gram plus 1.5 gram plus 1 gram equals 3.5 grams. Similarly, even in molecules, the molecular mass is always the sum of atomic masses of the elements present in a molecule. Look at the methane molecule here. The atomic weight of one carbon atom is 12.011 atomic mass units, AMU, and one hydrogen atom is 1.008 AMU. These values are used to obtain the value of one molecule of methane, which comes out to be 16.043 AMU. Formula mass. Some substances like sodium chloride do not contain discrete molecules as their constituent units. They contain positive sodium and negative chloride entities arranged in a 3-dimensional structure. The formula mass formula weight of a molecule is the sum of the atomic weights of the atoms in its empirical formula. The empirical formula is also known as the simplest formula. It is used to indicate the mole ratio of elements present in a compound. The formula, such as NaCl, is used to calculate the formula mass instead of molecular mass, as in the solid state sodium chloride does not exist as a single entity. Thus, formula mass of sodium chloride NaCl equals atomic mass of sodium Na plus atomic mass of chlorine Cl equals 23.0 U plus 35.5 U equals 58.5 U.